Hi everyone, good morning, good noon, good evening, wherever you are, and welcome to my YouTube channel and welcome to another Visuals with Maan. Okay, so in this session, I will be able to share to you my excitement, okay, when Gemini AI has able to provide a Python script that would help me visualize about Riemann Zeta function and the Euler product function. So let me tell you more about it. Okay, so the story of Riemann Zeta function started with a simple problem of adding the reciprocal of the powers. Like for example, what's really the value when we add up everything that looks like this, you know, like 1 over 1 squared plus 1 over 2 squared plus 1 over 3 squared and so on and so forth. Okay, and then you increase the exponent of the denominators to 3, 4, 5, what have you. Okay, and then they're able to formalize, all right, that it is a convergent function that looks like a divergent function. So with the help of J.H. Hardy, is able to provide a foundation about divergent function, that perhaps it's good not to dismiss them as nonsense. We can provide analysis for its structure and behavior. Perhaps we can determine that, oops, it's a convergent function anyways. Okay, all right, so for the Riemann Zeta function, this is denoted by this beautiful symbol here, and at the right side of the equation we have the Euler product. Okay, so basically for the Euler product, what we are doing here is that we key in prime numbers here and then raise it to negative s, and the s is the power, either powers of 2, powers of 3, powers of 4, and so on and so forth. So what is the meaning of this notation here? So basically we are going to have one term at a time, and for one term we key in what if p is 1 and s is 1 and what's the value, and p is 2, s is 2, what's the value. Okay, and then whatever is the value of that fraction, we multiply those values all together. Okay, and that's the Euler product. We're not summing up the values of this function as we substitute values of p and s, but we are multiplying. Okay, all right, so this is the Riemann Zeta function curve. So we start at s greater to 1 and very close to 1, so it's a very big value here for the exact value, and the Euler product is very much far from the exact value. See, the absolute error is 4.7. What's happening here? Because we are not able to key in a lot of prime numbers. But as we increase the number of prime into our Euler product here, okay, see, the absolute value decreases and the value of the Euler product becomes approximately equal to the Riemann Zeta function value. Alright, and then as we move along the Riemann Zeta function curve here, so we increase the s, we have powers of 2 here, and then we have powers of 3 here, powers of 4, powers of 5, and powers of 6. So we can visually see here that the exact value of the Riemann Zeta function and the Euler product value converges close to 1. Okay, because again, the expansion of the Riemann Zeta function and the Riemann Zeta function is we are adding up, right, the reciprocals. So we start with 1. Okay, 1 plus 1 over 2 squared plus 1 over 3 squared and what have you, because so we already have the 1 there. Okay, so the series, the convergent series, totally approached to a certain value close to 1. Okay, so as we increase s here to be more close to 1, all right, let's have a little about metacognition. So if you learn math, it's really nice to engage with AI and Python and GeoGebra, what have you, to visualize it, to have a tangible experience so you can retain the information. It's not just looking at the symbols and the notation. And another metacognition tip also is to have a manual calculation of it. Okay, but for now, I'm okay with this one. I did not have a manual calculation. Now I have really fully grasped what Riemann zeta function is. Okay, that we are just simply adding the reciprocals of powers. So again, this is your tutor Maan. I hope that you're happy with this moment of togetherness at this session. So I'll see you to the next Visuals with Maan. Bye for now.